Okay, so I want to do number 18 on 14.1, which has everything kind of labeled by 2's. So there's this contour map where the contours hit the x-axis at 2, 4, 6, 8, and the contours themselves are z is 2, z is 4, z is 6, z is 8, z is 10, kind of so on. And then there's y values that are also kind of 2, 4, 6, 8, give or take. And I realize I'm not doing a faithful job of interpreting this. So they want me to estimate fx at 3, 5. So what does that mean?
Go to position 3, 5.
Okay, so that means I'm thinking about being at the point 3, 5, right? Okay, so I need to get out a little fellow, and I need to put my little fellow at 3, 5. Right?
So 8.
Okay, so if I had to estimate my height, right, what would f of 3, 5 be? Give or take?
About 9.
Yep. It's between 8 and 10, right?
Yours is like right on 10.
Right on 10.
Yeah.
Oh, theirs is right on 10.
I always had a problem with that one.
Okay, so my little picture and the picture in the book are not the same. But the idea should hold, right? If I want to estimate this height, right, I would go to that point and then figure out about what contour line I'm on or which contour lines I'm in between, right? That's estimating the z value, though. What the heck is the fx value?
Rate of change at that point.
Yeah, that's the change in z per change in x. Okay, so that's your little fellow standing at 3, 5, wondering which way. He's going to look to, he's going to look kind of left or right, yeah? Like this way?
Yeah,
So if he looks that way, right, he's standing on his surface and he's looking. First, can you tell me whether that's uphill or downhill?
down.
Downhill?
Z is decreasing.
He's going up, it'll be uphill, right?
Sorry, say again?
If he's going, what direction are you asking? X out or what?
So in the positive x, right?
So, yeah, no.
So per change in x tells me he's looking along the, or parallel to the x-axis at least. And that's in that direction downhill. Behind him, of course, that's uphill, right? You guys all see that? So this is negative at the very least, because I know he's looking downhill. And then how in the heck do you figure out how downhill it is?
Approximate a rise over run.
Yeah, you want to approximate rise over run, right? That seems like it makes sense. So it seems like if he went over a unit from 3 to 4, he would go down from
9 to 8.
9 to 8 in my picture. And so I think I'm kind of saying 1 for 1, right? 1 z change for 1 x change. In the picture in the book, if we go to 3, 5, it's right at 10. And if I go over 1, it seems like I probably don't go down a whole unit, but maybe. I feel like this is pretty close to what you would be getting in the book.
It is an approximate x.
You guys see that? Yeah, it is exactly approximate.
Oh, the answer is just an approximation?
Yeah, the answer is just an approximation. So this is an approximation. Is it the best one? Probably not. Probably the back of the book has what? -3/4 or something?
Negative 2/3.
Yeah, so I would say it's probably a little bit smaller than 1 just because like 1 unit doesn't seem to get you halfway down the contour line in the book's picture. that seems like it makes sense, so I just shave a little off, basically. You guys cool with that? Or you could figure out in the book's picture, they're standing like here, right? And so they're saying, okay, to get to the next contour line over, right, to drop 2, right, that's a -2 in the z, it takes me how many units in the x, and they kind of count it out and figure out that it's 3. You guys see that's a like, slightly different approximation, but it's really just the difference between my pictures. You really just want to go find the rise over the run for that specific variable, right? If you wanted to do the Fy at 3,5, which direction did you look in?
What happens when you
Yeah, you'd look up, right? So you'd think your change, right, your run units are up now, and your rise units are still rise units. They're still out of the board. What's up, Ron?
So for one of these, if they wanted you to look, you know, either down in the y direction or to the left in the x direction, that'd be like negative f of x or negative f of y, or is it written a different way?
Yeah, so I think we'd write something like this, right? We'd say, well, it's like my f minus
Okay,
y
yeah,
at
fine.
3,5 or something.
Okay.
Yeah, that's.
Is that something they'll have us do, or?
Oh yeah,
Okay.
and actually this is the topic for today. We're gonna do what are So when I gave you guys this symbol, I watched the video this morning and I realized that I said directional derivative. These are partial derivatives. A directional derivative is exactly the idea you're talking about.
Okay.
And it turns out that this would be equal to minus Fy at 3,5. Which makes sense, right?
Yeah.
Like,
Yeah.
if you're looking this way and it's downhill, then behind you is uphill at exactly the opposite, right? You guys all see that? So later today we'll have a way to do this. You just, what the hell? I'll give it to you. So, I probably should look at notation, but there's a bunch of different ways to do this. So one of them would be to do like f and then write a little u vector and put a point, right? And this would mean f's derivative along the u direction at 3,5.
Okay.
And the way I would do that is I would take kind of derivative information, right, for both directions, which might be the gradient of f, right? Evaluated at 3,5. And then that's, let's see, that's a vector, right? And the directional derivative, right, should be like a slope of a tangent line, right? So that should be a scalar. And I should still incorporate that u information. So how do I take two vectors and make a scalar out of it?
dot product?
Plug in the point, right?
Yeah, it's just dot product it. So I need to plug in the point to make this a scalar, right? Because otherwise it's a vector with variables in it. I want it to be a vector with scalar coefficients. So I would evaluate at that point, and then I want to dot with that u vector. And the one caveat here is that I should add that u should be a unit vector.
Wait, so u in this case is 3,5 or?
Yeah, so the u in this case is undecided.
Okay.
Right, the 0.35 is where I'm talking about standing, right? So I'm standing at the 0.35, and then the u is which direction am I looking in? So for fx, right, I'm looking in the I direction. For fy, I'm looking in the j
Oh, it'd be
direction.
like 1, 0 or 0, 1 then, or?
Yeah, so in my two examples, right, of fx and fy, I'd be looking in the 1, 0 and 0, 1 directions, right? So we could write fx as f1, 0. Do that to make it obvious what the heck I'm doing. You guys cool with this? If I wanted to look in a different direction, like say the minus y direction, right, I would write f sub minus j. And then I would take the gradient and dot it with, what would the minus y direction be as a vector? Just be negative j, right? So that's going to strip off the fy information and then tack a negative sign on it. So I'm going to get this example. You guys call that? We'll do a few examples later.
So that's the general formula that we have to do.
Yeah, so this is the, this is the apparently general form for the directional derivative in the u direction evaluated at the point 3, 5. Like, I picked 3, 5 because that was in this problem. The more general formula has a, like an a and a b there.
Yeah.
You guys cool? Good question.